Alright, so the first few problems are area problems given side angle side, and here is the setup. So you just replace the A and the B with the side length, 6 and 10. I always just simplify this. If I can just do it quickly in my head, I just do it. So 60 divided by 2 is 30. Sine 110 into the calculator, and you get this. Now they didn't give you a unit for the side, so you just write square units. 37 is exactly the same. Sine of 150 happens to be 1/2. It is one of the special angles, so I just replaced that sine 150 with 1/2. And 80 divided by 2 is 40, so then you end up with 20 square units. 39, just make sure you use the degree minute second key when you input it here or here, right? And so this is what you get, and don't forget the square units. Okay, so the first three are pretty straightforward. Just plug them into that one formula, and this one, just be careful that you input the degree minute second key each time after the 75 and after the 15. 49, I forgot to tell you, only do part A. So here it is. Sine of alpha, you're looking for this little angle in here. This is a right triangle, where this is 5.45 and this is the hypotenuse 58.36. So sine of alpha is this, opposite over hypotenuse. And to find the angle, you do inverse sine of this ratio, and then you get this angle. 51 through 53 are true and false. So for 51, it says if any three sides or three angles of an oblique triangle are known, then the triangle can be solved. Not necessarily. If you have three sides, yes. But if you have three angles, it could be an infinite number of triangles, because just knowing the three angles doesn't put a lock on the sides. Okay, the sides, you need to know one side. So AAA does not determine a triangle. But if you know three sides, yes. But since it says, it includes the angles in this statement, you have to say it's false. 52, if a triangle contains an obtuse angle, then it must be oblique. So if it has an obtuse angle, it must be oblique. Yes, that is true. 53. Oh, and it says to explain, right? Justify your answer. Well, you can't have an obtuse angle and a right angle in the same triangle, right? So then if you have an obtuse angle, it has to be oblique. It can't be a right triangle. For 53, two angles on one side of a triangle do not necessarily determine a unique triangle. Now, because it says do not necessarily determine a unique triangle, that statement is false. Because if you know two angles and one side, it's either a side angle or an angle side angle, then you do have a triangle. It does determine a unique triangle, so this statement is false.